A relay is a simple electromechanical switch made up of an electromagnet and a set of contacts. Relays are found hidden in all sorts of devices. In fact, some of the first computers ever built used relays. Relays are amazingly simple devices. There are 4 parts in every relay: electromagnet, armature that can be attracted by the electromagnet, spring, a set of electrical contacts. You can see in this picture that a relay consists of 2 separate and completely independent circuits. The first is at the bottom and drives the electromagnet. In this circuit, a switch is controlling power to the electromagnet. When the switch is on, the electromagnet is on, and it attracts the armature. The armature is acting as a switch in the second circuit. When the electromagnet is energized, the armature completes the second circuit and the light is on. When the electromagnet is not energized, the spring pulls the armature away and the circuit is not complete. In this case, the light is dark. In general, the point of a relay is to use a small amount of power in the electromagnet coming, say, from a small dashboard switch or a low-power electronic circuit to move an armature that is able to switch a much larger amount of power. This is what is done in motorcycle or automotive starter systems to control high amperage power to the starter. Relays are quite common in home appliances where there is an electronic control turning on something like a motor or a light. They are also common in cars where the 12-volt supply voltage means that just about everything needs a large amount of current. In later model cars, manufacturers have started combining relay panels into fuse boxes to make maintenance easier. The tools and supply needed to build a simple relay are 2 18-gauge braided 6-inch long wires, 1 alligator clip, variable speed drill motor, 12-volt power supply, 9-volt battery, soldering flux, hammer, jumper wires with alligator clips, thin magnet wire, 1-inch wide masking tape, large nail, needle nose pliers, razor blade or sharp edge, straight or Phillips screwdriver, single core insulated 6-inch copper wire, solder, soldering iron, small block of wood, small wood screw, wire strippers, crimpers, and an automotive light socket and bulb. Take the nail and lay the magnet wire along the side of it, with at least 3 inches hanging past the end of the nail. Tape the wire to the nail with the masking tape. Insert the nail into the drill motor. Slowly rotate the nail with the drill while trying to get the wire to lie neatly on the nail. Continue adding wire until the wire is slightly bigger than the nail head. Once done, tape over the coil that you just made to hold it in place. Cut the wire from the spool end at least 3 inches from the nail and remove the nail. Use a razor blade or sharp edge and scrape the coating off the end of both wire ends. Hammer the nail into the center of the block of wood. Using the wire strippers, strip the wire back about 3/4 of an inch from both ends of the 2 braided wires and the single core wire. Put soldering flux on the bottom of the nail and solder one of the 6-inch long braided wires to the bottom of the nail. Once the solder cools, give the wire a slight tug to make sure it is soldered well to the nail. Using the screwdriver, start the wood screw into the corner of the board. Place one end of the 6-inch braided and single core wires under the screw, then tighten the wood screw down. Slide the alligator clip onto the other end of the single core wire. Crimp it on if needed. Bend the single core wire until the alligator clip is about 1/4 of an inch above the nail head. The wire should have a nice arc to it. Using one of the jumper wires, connect the positive power supply cable to the light bulb. If you are using a dual filament socket and bulb, connect it to any of the 2 wires. Using the other jumper wire, connect one end to the ground on the light socket and the other to the wire that is connected to the wood screw. If using a dual filament bulb, the ground is the metal on the socket. Connect the negative power supply cable to the wire that is soldered to the nail. Test the connection by pushing the alligator clip onto the nail head. The light bulb should light. Hold one end of the magnet wire onto the negative post of the 9-volt battery and briefly touch the other end to the positive post. The alligator clip should be drawn against the nail head and the light bulb should light. If the alligator clip is not drawn down against the nail head, adjust the clip closer to the nail head. If the alligator clip gets stuck on the nail head without the 9-volt battery being hooked up, adjust the clip farther away from the nail head. Do not keep the wires hooked up to the 9-volt battery for long. It will drain the battery quickly.